So we've been talking about systems, and systems means that there's more than one constraint that needs to be considered. So if we're talking about two equations, the point needs to make both equations true. If we're talking about just a word situation and there's no equations, you just have to make sure that both things are satisfied. So even though this Facebook thing includes equations instead of variables, it's got fruit pictures. You can use substitution very easily in this. You've got a clear piece of information right here in the first equation. If you know that there's going to be 3 apples that are 30, then each apple has to equal 10. Once you know that, then you can substitute that information in for all of the other apples and then use that to find what's missing. So if 10 plus 2 bananas is 18, then the 2 bananas have to equal 8, and you can go on from there. So a banana is going to equal 4, and then 4 minus a coconut is 2, so coconut has to be 2, and a banana is 4. So you're substituting what you know to figure out what you don't know. We can solve with graphing or from a table. So here we did this. If you watch the other video, it's the exact same thing. If we have graphed y equals x minus 2, the pen's not working. Y equals x minus 2, which is this one. All the points on y equals x minus 2 are right here, including when x is 0, y is 2. When y is 0, x is negative 2. You can pick any point on this line and put it in here, but we also know it grows by 2 each time. So, no, it grows by 1 each time, my bad. So like if we had negative 1, it would be 0 plus 1, and we already know that 0 is 2. So that's all those points. And then 2x minus 1, all of these points are going to be solutions to y equals 2x minus 1, but there's only one point where they're the same. So 2x minus 1 is 0, negative 1 is our starting amount because it's our y-intercept, and it grows by 2. So we can go ahead and we get 1, 1, and it goes by 2, we get 2, 3, etc. We could go backwards if we wanted to. Negative 1 would be 2 less, so it would be at negative 3, and sure enough, here it is, negative 1, negative 3. But the point that makes both of them true, the common point that makes both of them true, is 3, 5. So when you're solving with substitution, if you know one thing or one value, you can replace it. So instead of this being an apple, I know that a y is going to equal x plus 2 in this one, and y equals 2x minus 1 in the other one, and we're looking for when they're the same. So we're going to go ahead and set these two equal to each other. We're going to put the x plus 2 equal to 2x minus 1. We're looking for when they intersect. We're looking for when they're the same. And then we're just going to go ahead and solve the equation. Remember, when you have the two variables on both sides, you just have to get started. So choose an action that's going to let you get the variables on one side and the numbers on the other. I'm just going to subtract x. That's what I'm going to do. And that'll get us started. Remember, like terms. So the x's have to go with the x's have to go with the x's. This is what I'm talking about. X's with x's, okay? And so when I combine the like terms on the left side, all I have left, whoops, wrong pen, is a 2 on this side, and all I have left is a singular x on that side. And then I just need to finish solving the equation to find out what x is. I'm going to add 1 on both sides. So I find out that x is 3. But I need to know the whole point, not just the x value. So we already know the x value. So to find the y value, all you got to do is plug it into either of those equations, and you'll find out what the y value is. So I'm going to pick this one because it looks easier. So I'm looking for what y is when x is 3. So 3 plus 2 is 5. So the y value is 5. And so we can find the value of the variable without graphing it, without guessing and checking, without making a big table, by solving it algebraically. Okay, it's possible also that you might end up with two functions that are not both solved for the same variable. This one right here is in y equals form, and this one is not. So you have a choice. You can take the blue one and you can rewrite it into y equals form and set them equal to each other like we did in the previous slide. Or you can take what you know about what the value of y is in the first equation and put it in for y in the second equation, because you're trying to find out when the y's are equal. So you can go ahead and put them together. And that means you're going to have 2x from this right here and 2 times y, and we already know in one of the equations that y is equal to 2x plus 5, and then that's equal to the 10. So all we did was take what we knew about y in one and replace it in for y in the other. We're substituting just like we did with the apple earlier. Now this is a pretty complicated equation. Some of your equation solving skills not a problem, so you can probably scoot through this, but I want to explain it a little slower for some people. And I'm going to go ahead and nope, that's not how I do that. Anyway, sorry, I'm not using my tool very well here. The first thing, this left-hand side, you're going to want to go ahead and simplify that. And simplifying it might be to distribute, which is what we're going to have to do, and then combine like terms. Remember, like terms have the same variable and the same exponent. So in this case, our like terms are going to have x's and then numbers. Those are the two different like terms we have here. We'll talk about that in a second. So first we're going to distribute. And this 2x isn't attached to anything, but this 2, there's two 2x plus 5s, so we're going to have 4 x's, and 2 times 5 is 10, and that equals 10. So now we've distributed, and now we're going to look at the like terms. Now like terms are the same variable and the same exponents. 2x and 4x can go together, and that's what you want to do in your solving equations. Simplify each side first. So we get 6x. That cannot go together with the 10, they're not like terms, equals 10. Now I notice that there's a 10 on each side, and if I subtracted 10, this one would disappear on this side. So now I have 6x equals 0. And 6x equals 0, then you can either tell that x has to equal 0, because that's the only way you multiply 6 by something, you'll get 0, or you divide it. So you're like, okay, it's a multiplication problem, I'm going to divide by 6. And I find out that x is going to be 0 divided by 6, which is 0, right? Once you find out what x is, then you can go ahead and plug it into either equation. So I don't care which equation, because once I know what x is in one of them, I'm looking for where they're the same. So I'm going to go ahead and I'm just going to choose this one. So 2 times x is 0, 2 times 0 is 0, and 0 plus 2y is 10, so y is going to equal 5. So these two share a common point at 0, this is messy, at 0, 5, which is the y-intercept of both of the equations.